So I have explained to you what is critical path method. A macro level understanding of critical path method has been given in my earlier sessions only. Now let's get into the details. We'll take example, and along with the example we'll understand this complete methodology. So our project is, let our project be publishing of a book. Project is publishing a book. Okay, this is our project. So what will be the first activity? It will be, when you have to publish a book, there has to be a manuscript. For example, if I want to publish a book, I'll write it in my notebook. That will be a manuscript. That has to be proofreading. Editing has to be done. So manuscript proofreading. What is this? You must be knowing. I'm just telling you. Manuscript is written. I have written the book. Then what I have done? I have given it to someone who has typed it in a computer, and then final printout is out. So that is called manuscript proofreading. Reading it again, the final whatever has come out. So read it. If there are any errors, you have to rectify the errors. So first activity is manuscript proofreading. Second activity will be to print certain number of pages, sample pages. So sample pages printing, because you will obviously want to see how it looks as a book, whatever you have written. So printing of some sample pages will be the second part. Third will be preparation of artwork. Every book, even the book you are holding right now, if you are having a book, you'll see there are several artworks. If you may have diagrams, you may have figures, you may have pictures of certain monuments and all. So artwork preparation will be your another activity. Someone will be working on it. Fourth will be book cover design. Obviously a book will have a cover, so you'll need to design the cover. Okay, so these are the first four activities if you want to publish a book. Now after that activity, the next activity will be editor will, let's say, pass all these. Editor will pass these all these, that is manuscript proofreading. The editor checks it and says okay, this is okay. Sample pages, he also inspects the pages and says correct. Artwork, he verifies the artwork, and finally book cover, he is happy with it. So fifth step will be this. So let's understand up to this. How we, in a network model, how we express an activity. We have two nodes that are events, and we have an arc which is activity, and it is directed because your work will start and end here. This is the way in a network model. So if we start at, let's say, our starting point is, let's say, first activity is manuscript proofreading. So let us define it as A. This activity is A. So we can say this is A. Similarly, we have sample pages printing. You very well understand that you don't need to first of all do the proofreading of manuscript and then only start sample printing. You don't need to do this. Why? Because you want to see the font, you want to see how many lines are in one page. So this can be done concurrently. So let's say this is your activity B, that is sample page printing. Then is artwork preparation. Someone can sit and design the artwork. So that is your next work. So let it be C. So this is C. Then I'm writing it here, activities. Book cover design, that can also go like this. Okay, clear? But after these activities have been done, then only editor can pass. Before that you cannot pass it. Next, when editor has passed, let's say this is your activity E. Editor will pass all the four. Then what will you do? You'll do book formatting. The next step is to format the book. because all these have been passed. So now you can do with this book formatting. Then again editor will pass this, okay, and when this has been passed, you just print it. I'm not going into very details of the activities. There will be hundreds of activities involved, but at block level you can put it like this. So let this activity be G, this activity be H, this activity be I. So we have defined activities. We have not defined the time duration. Let's say you have understood what these terms are. So I'm rubbing from here to here. Okay. We'll make 2 more columns. This is activity. Let's put predecessors here. What needs to be done before this activity is done. And the next is time or duration, whatever you say, time or duration. So you don't have any predecessor, manuscript reading, sample page printing, no predecessor, artwork, no predecessor, book cover, no predecessor. But editor will pass this. Until unless these 4 have been done, what the editor cannot pass this. So the predecessor here will be, I'm writing in red. So A, B, C, D. So these activities need to be done before activity E is done. Now book formatting. Until and unless this E has been done, you cannot go to G. So here you have a predecessor, that is E. Here again G is done, then only you can go to H, and when H is done, then only you can go to I. You will print only after it has been passed. So this is predecessor, your next column. And let's say time, just random basis. Let's say manuscript reading takes 10 days. Sample page printing takes 2 days. Artwork preparation takes 12 days. Book cover design takes 5 days. So let's write it here. See, A, it takes 10 days. B, it takes 2 days. C, it takes 12 days. And D, book cover design, it takes 5 days. Now all of them need to be completed before you go to the next level, that is, let's say this is your 1 to 6. So your E activity is completed only when you have completed all of this. Now you see this takes 12 days. So obviously 12 days is required here. So what we do, we connect it like this. This is your activity H, and we create, these are called dummy activities. That is, they don't require dummy activities. Why dummy? They don't require time and resource. No time and resource. But they are very helpful in network modeling. So let these be dummy activities. So minimum time from here to here required is 12 days. You'll complete this in 10 days. 2 days that will be kept on the disk. All the other activities will be before this, but they'll have to wait. Once this is completed, what do? We go to the next activity, that is H. And we know, we don't know. Let's say editor passing this takes 2 days. So this will take 2 days. Now book formatting next takes 5 days. This again takes 2, and this takes 10. So after this E, after this point, you'll have another point, another node that will have activity G, book formatting. So G5. From there you'll go to activity A, and this one G we have done. G is, see, E, H. After H we have reached up to this point. No, actually this was, I just got confused. So this is not H, this is, editor will pass, this is E. So this is E. Then after E we have activity G. I have just slipped F, let it be. So this is G. Then from here you have next activities, that is H, and it takes this much. Okay, these are predecessors. So H takes 2, and then finally you have printing, and your project is completed. This is I, which takes 10 days. Clear? These 4 activities need to be done. Then the first activity is editor passing all these, that will take 2 days. Then book formatting 5 days. Then editor passing it again 2 days, and then finally printing it 10 days. Clear? What is the total time taken to complete this project. It is the longest path. If you calculate the time requirement for the longest path, that is it. See, from here to here, you have 12 days. So 12, you cannot take this because this is smaller than this. So 12 plus 2, 14, plus 5, 19, plus 2, 21, and 10, 31. That is, you will require minimum 31 days to complete this project, publishing of this book. Okay. Now our next step is network computations. Let's understand by this network model. These are nodes, these are activities, and these are the time taken by each activity. For example, B takes, let's say, 6 days, C takes 3 days, A takes 5 days, D takes 8 days, and so on. So how we compute critical path method computations, CPM computations, or network computations? What we do? See, for computation, we need to understand and define critical and non-critical activities. Which activity is critical and which activity is non-critical? The basic definition is, if the start and end times of an activity is defined, it is determined, that is a critical activity. But if the start and end of an activity, this time is more than the duration required for that activity, it is non-critical. Let me explain. In the last example, I told you that there were 4 activities. Let's say I'm writing 3 activities. Manuscript reading, it took 5 days. Then artwork, let's say it takes 12 days. B and C, cover design, let's say it takes 6 days. But I told you that what you'll have to do is you'll create dummy activities here. Only after this activity B is completed, then only you can go to your next activity. So this takes the duration of completion of activity C is 6, but you have a window of 12 days. That is, if on 1st of, let's say 1st of January you have started, then you'll have to wait till 12th of January. You'll start only on 13th of January, you'll start the next activity only on the 13th January. So your B activity will fill all this gap. That is, start and end dates are determined. But activity A, it takes 5 days. So you can also do, what you can do, you can start it on 7th day, or you can start it on 6th day and complete it on 11th day. Likewise, C, activity C. So it takes 6 days. So if you start on, let's say, day 3, you'll complete it on day 9. So when the time allotted is more than the duration required to complete the job, it is non-critical. But if the start and end dates are fixed, it is critical. So here we have this activity B as the critical activity, while your A and C are non-critical activity. Clear? Now, when you have understood what are critical and non-critical activities, you'll understand what is a forward pass. Forward pass and backward pass. These are 2 ways for computation of the time schedules. What is forward pass? It is denoted by a square or a rectangle on this map, on the network model, like this. What is forward pass? If we say this started on day 1, see, up to this point, if you go by this activity, it will take 6 days. But through this path, it will take 5 and 3, that is 8 number of days. 5 plus 3. So if you start it on day, let's say day 0, starting date, day 0, you start at t equal to 0. You may complete it by 6, but you will have to wait for another 2 days. 5 plus 3, 8. So you will reach here only on 8. 0 plus 8, 8. So although this takes only 6 days, this is on 8th day. Next, come to this point. From here to here, this will take 5 days. Clear? Now see, this one. Here to here you don't have any other node. The only activity is this only. So if this is on 5th day, 5 plus 8 will be 13. That is, you complete activity A. After this you do another activity C for another 3 days. This can be done concurrently while you proceed to this path. That is 2 to 4. This activity 2, 4. It will take 8 days. So 5 plus 8, 13. What about this point? Let's understand. This does not require any time and resource. So we have 5 plus 8, 13. So you can reach here by 13th. So through this path is 13th. Let's see through this. 8 plus 2, 10. That is, if you go by this 1, 3 and 5, you'll take 8 plus 2, 10 days. But this is 5 plus 8, 13. And you know the maximum value is to be taken. So this becomes now 13. Okay. I'll define critical and non-critical. First of all, let's understand what forward pass is. Clear? Now come to this activity now. See, we have reached here on 13th day. This is 13. From here to here, you only take 1 day. This activity takes only 1 day. But can you complete this work in 13 plus 1, 14 days? No. Why? Because from 13 you have another 12 days for the activity H. So this is 13 plus 12. Now let's see if this is the maximum or so this is maximum. Here it is 8. 8 plus 11 is 19. So if you go by this path, you can reach here in 19 days. If you go by this path, you can reach here by 14th day. And if you go by this path, 13 plus 12, that will be 25. And you know the maximum number of the days, that is maximum time is to be taken. So your project will be completed on 25th day. This is forward pass. Day 0 we start work. Day 8 our work B, A and C is complete. Day 13th our this 1, 2, 3, 4 all are completed. Day 25 every work is completed. So we start here and go up to this point. This is called forward pass. Now in forward pass, how we define critical activities? What are critical activities and what are non-critical activities? See, the basic definition of critical activity is, as I told you, that the start and end date should be fixed. That is, the duration and start and end of date should be equal. So this is 0 and 5. This is 5 minus 0, 5, and duration is 5. So this is equal, this is critical. This path is critical. Then it will go on, you don't need to consider it. Again, come to this point. This and this, see 13 minus 5, 8. Again, this minus this is equal to 8. You can see this minus this is not equal to 6. 8 minus 0 is 8, but this is 6. But this minus this is equal to this minus this is equal to this. So this is critical. Then this and this. 25 minus 13, 12, but this is only 1. So this is not critical. But 25 minus 13, this is 12. So this is your next critical path. So your critical path is this. 1, 2, 4, 5, 6. That is, this is the longest, this is the path that takes longest time. This is the critical path, and the time taken by this path is the time of this project. Why do we call it critical? Because the start and end dates are fixed. If you have any delay, it will completely disturb your project time. Let me explain to you why. Let's start with this and this. If we start activity A on day 2, this will now become 5 minus 2, 7. So finally you will have 27 number of days. That is, completion of your project will take 27 days. This path, if this is 5 and 13, if you delay by 2 days, this will become 15. Again, this will be 27. Same as with this. But what about this? If instead of starting this project B on day 0, we start it on day 2, no issue. Again, it will be completed. See this one. This is 8 minus 5, 3, and this is 3. This should be critical. But why it is not critical? Let me tell you why. If you take one more day, what will happen? Instead of 8, this will become 9. 9 plus 11, still it will be 20, which is less than 25. So even if you have delays in these paths, 1 or 2 days, it won't affect your overall time duration of the project. But if you have any delays in this and this one, your time for the project will be delayed. So the most important activities, the critical activities for time scheduling are this, this and this. Clear? And the time taken in this path, that is the total time taken for the project. So this is from 0 to 25th day, this is forward pass. Clear? So this was forward pass. Now let's see backward pass. Backward pass is denoted by a triangle. What we do, here we have 25, let's say this is 25. What we do, we get backwards. That is on 25th day, we have to, let's say this is April. So we have to complete it on 25th April. Then see, 25 minus 12, this will be 13. So this point is 13. Okay. So this point is also 13. No issues. But if we had gone by this path, 25 minus 1, this could have been 24. But we'll have to take the minimum value. So this will be 13. Although on 24th day also we can start. But this point will be reached if we started on 25th, this will be 13th. I'll tell you why we do this. 13 minus 8, this is again critical. So this will be 13 minus 8, that is 5. This will be 5 and finally this will be 0. So critical path, all the values are same. What about this? This is 13. 13 minus 12 will be 11. Although 25 minus 11 is 14. But you need 13th day here and then 2 days here. 11 minus 6 will be 5. But you have to come to 0 point. This will be start. Now, what is the difference? When we point out the forward pass points, we say that at the latest, this activity has to be completed on the 5th day. If we have started on day 0, on day 5, this has to be completed. On day 13, this has to be completed. This is forward pass. Backward pass, what we do? Here we said D activity, or start with this. In forward pass, what we say? Activity A has to be started on day 0. Activity D has to be started on day 5. Activity H has to be started on day 13, so that we complete our project on day 25. By backward pass, what we say? We say our completion date is 25th. By 13th of this, these activities have to be completed. 13th of this, A and D has to be completed. By 5th of this, A has to be completed. That is, in forward pass, we determine the start date of every activity, and in backward pass, we fix the last date of completion of every activity. So this is just a way to, analyze it. For example, you are constructing a building, you will explain to the engineer that by 15th of April, your roof casting has to be done. This is one way. Or the second way is, by 10th of April, you have to start casting of roof. So the second one is forward pass, and the first one that I said that by 15th of April, roof cast has to be completed. So that is backward pass. So this is a way of analysis of the model. Okay. So I think you must have understood what is forward pass, what is backward pass, and what is critical path, what are critical activities, and what are non-critical activities. These are explanations. Later on also, we'll solve some examples. We'll see several examples to understand this. So when this is clear, now we come to the time scheduling. How we schedule time. We have defined everything. What we do? See, we will make sort of graph. Let's say this is your graph. We stagger the critical activities first. That is, let's say this is 5. No, this won't be in a scale. So let this be 5, 10, 15, 20, 25. These are number of days. Okay. And these are the activities. So we'll start with activity A. So 1 to 5, we have to complete it. Activity A, 0 to 5. So let's say this is the first activity will be this. This is A. This is put in solid type. Then we have this activity D, which takes 8 days. That is D. But between D takes 13 days. So D, we start D here, and this is 15. So let this be this point. So this is your D point. D takes 8 days. And then is your H. H takes, it will start on after this. So let this be the point, and it will go up to this point, 25th day. So this is H12. ADH, all in solid lines, staggered. So we know these are critical activities. We have to complete it in 5 days, this in 8 days, and this is in 12 days. Now, non-critical activities, we use dashed lines. We can start this at day 0, this B, activity B. So we'll start this like this, dotted line 6. This is B6. Okay. When this is complete, then we can go for this. So A is complete, then we'll go for C, which will take 3 days. Okay. C will take 3 days, and we have to complete it by 8th day. So C takes 3 days. Now let's see E. E takes only 2. The duration is 2, and we will start with 8th day. The duration for this is 2, but it can go up to 13th day. Say this is somewhere 13. So this is your activity E. Although it is a very small activity, but you have from 13 to 8, that is, you have 5 days time. You can start any day and complete it. Then you have F, that is 11. You can start on after this 8th. So this is from here you will start. No, actually this is 8th day, not this. So A5 and 8. So you can start it somewhere. 8 is around, let's say this is the 8th point. So from here it goes up to final 25th day. So you can go up to this. This is your activity, which is F. This is activity F. It takes 11 days, but you have 25 minus 8, that is 25 minus 8, 17 days. You can do this 11-day work in any of these 17 days. Then any activity left, this is G1. It takes only days, but you can start on 13th day and end on 25th day. See 13th, this is 13th, and up to this last date. This is G. So this is time scheduling. This way we schedule it. Clear? Looking at this only, you understand it has taken 5 days, but the work is only of 2 days. So in all these 5 days, we can use this, and it is non-critical. So even if it takes, instead of 2, it takes 5 days, that won't affect our project. But if we have any delays in these activities, our project will get delayed. Clear? So this is time scheduling. What we did, we defined activities. We had a network model, then we did network computations. We decided the critical path, the total time, and then this is your time schedule. Now the final part. We defined 2 terms here, total floats and free floats. What are these? We define it for non-critical activities. Non-critical activities. What are the non-critical activities? B, C, I'm writing B, C, then D is critical. So E, F, G. These are non-critical activities. But our A, D and H are critical. So we have floats for non-critical activities. You'll understand it very, just in 2-3 minutes you'll understand what it is. First is total float. What is total float? You have forward pass. So forward pass minus the actual duration. The difference in forward pass, that is, here we have the time point is 8. So 8 minus 0, that is 8. That minus the actual duration of this work. So that is called free float. So 8 minus 6 is 2. This is free float. 2 days is free float. And total float is this. Your backward pass, backward point minus this. So 11 minus 0. 11 minus 0, so this is 11 and the duration is 6. So 11 minus 6 is total float. 11 minus 6, 5. What is the meaning of this? See, if on April 25th the work is to be completed, then you know this point you have to reach it maximum by 11th. That is, total float means that your activity B should be started by 5th, because you will take 6 days to reach here. So that is the starting point which it has to be reached. That is total float. What is free float? Free float is this minus this. That is, if you don't want to delay your project, you have to see the critical path, you cannot delay it. But even non-critical activities can delay your project if the time taken by a non-critical activity is greater than its free float. That is, see, free float is forward pass 1. That is 8 minus 6, 2. So if you start on day 3, so 3, 2, that is 1, 2, and then 3, 4, 5, 6, 7, 8. So on 8th day, this will be completed. But if you start it on day 5th, as you decided according to total float, then this won't be on 8th day. You'll complete it on 5 plus 6, 11th day. So if you don't want to delay your project, what you need to do is your starting point must be less than FF. See, 8 minus 5, that is 3, 3 minus 3, the duration. So 3 minus 3 is 0. That is, you don't have any leverage here. You'll have to start it the very moment you complete activity A. And total float will be 11 minus 5, 6, 6 minus 3. 6 minus 3, that is 3. You have 3 days from backward pass. Then come to this point. 13 minus 5 is 8, 8 minus 8 is 0. Oh, not D. D is a critical path. We'll go for E. E is 13 minus 8, 5, and 5 minus 2, 3. So 5 minus 2, this is 3. What is total float? 13 minus 11, 2. Then 2 minus 2. So you don't have any time left here. Then let's see F. F is 25 minus 8. That is 25 minus 8 is 17, and 17 minus 11, 6. So 17 minus 11 is 6. That is, you have leverage of 6 days. And this is 25. 25 minus 11, it will be 14. 14 minus 11, that is 13. Sorry, 14 minus 11 is not 13, it is 3. So 3 days you have. It can be delayed by 3 days. Similarly, G, 25 minus 13, 12. So 12 minus 1, 11. And this is also 25. So 25 minus 13, 12. 12 minus 1. Okay. So this way we calculate the free floats and total floats. So what we have learned from this, we have learned that free float is less than total float. And free float means this is the time that we can delay. A non-critical activity can be delayed by free float. You can delay. Free float for B is 2. So you can delay this by 2 days so that your overall project doesn't get delayed. F, it is 6. So you can delay this project by 6 days. Still you will complete it by day 25. This is the meaning of free float. So this is all about critical path method. I told you how to define the activities, how to have a network model of the whole project, then how to compute different timings, then how to schedule, and how to find free floats, so that your you are able to design feedbacks. Then your non-critical activity should be delayed maximum by these number of days. If it is delayed, then you must create feedback. You'll need to reschedule it. The days will be delayed, but you need to work on each and every node and each and every activities. Clear?